Hello everyone. As you know, we are dealing with the nitration of phenol as an electrophilic substitution reaction. In previous videos, I have told you nitration of phenol can be carried out by two chemicals. Number one, you can use dilute nitric acid. And number two, you can use the mixture of concentrated nitric acid and concentrated sulfuric acid. In previous videos, we have covered dilute nitric acid. Now we will start this one. Let's check. First, direct reaction. This is phenol. These two carbons are ortho. This is meta and this is para. When phenol is treated with concentrated nitric acid and concentrated sulfuric acid, on heating, nitration will happen. Nitration means add of NO2 group on a benzene ring and obviously ortho and para position. Now because the conditions are strong, concentrated conditions they are, what will happen? Nitro groups will be added on all three positions simultaneously. 2 ortho, 1 para. Means tri-substitution will happen. Tri-substitution. 3 hydrogens, 2 from ortho, 1 from para are substituted by 3 nitro group. The compound name, the common name is very important, picric acid. It is picric acid. Yellow color precipitates will generate of a picric acid while this reaction. If I talk about IUPAC naming, OH is a main functional group. 1, 2, 3, 4, 5, 6, 2, 4, 6 trinitrophenol. This will generate. Now, mechanism I will not discuss. Mechanism I have already discussed in previous videos. Like the mixture of concentrated nitric acid and concentrated sulfuric acid will generate nitronium as an electrophile. How they will generate nitronium as an electrophile already discussed in previous videos, please check. This nitronium ion being an electrophile wants electron. For electrons it will attack on benzene ring and obviously which positions? Ortho and para. Like this, suppose it is attacking on ortho position. How it will be added on ortho position already discussed in a mechanism of previous videos. Only the point is 3 times you have to use it. Once you have added here, one more nitronium ion will be added on para position and one more nitronium ion will be added on ortho position. Same mechanism. Please check that mechanism. Now the point is, what is the problem in this reaction? When we are reacting phenol with concentrated nitric acid and concentrated sulfuric acid, no doubt picric acid is generated as a nitrated product. This is picric acid, which we want as a main product. But the problem is, it is not a main product. Its percentage is only 10 to 25%. What is the reason why we are not getting high amount of a nitrated product? Because of concentrated nitric acid. Concentrated nitric acid is also working as an oxidizing agent. Like dilute nitric acid was working, same here, same problem. Concentrated nitric acid is working as an oxidizing agent, due to which many particles of phenol will get oxidation and they will be converted to benzoquinone, already discussed in previous video. This is the problem. Nitrated product is very less, only 10 to 25%, and most of the particles are getting oxidized due to concentrated nitric acid. Now, how concentrated nitric acid is working as an oxidizing agent, let's recall. Already I have told you how dilute nitric acid is working as an oxidizing agent. Two particles of nitric acid, dilute nitric acid, were reacting to create two molecules of nitric oxide gas, three nascent oxygens, and one water molecule particle. These nascent oxygens were oxidizing phenol to benzoquinone. How? Please check the previous video. Everything is given there. What are nascent oxygen? How they are working as an electrophile? How they are converting benzene ring of a phenol to benzoquinone? Everything is given there with mechanism. Concentrated nitric acid almost have a same reaction, but the change is at the place of nitric oxide, it is creating nitrogen dioxide gas with one nascent oxygen and one water molecule. One nascent oxygen will bring oxidation of phenol to benzoquinone. In this fashion, concentrated nitric acid is working as an oxidizing agent. Now, how it is creating one nascent oxygen? Let me tell you. The whole mechanism I will not tell. Please check dilute nitric acid case. It is similar. From here it will be little differ. When you will check the case of dilute nitric acid, how it is working as an oxidizing agent, you will find out one intermediate was generated there, nitrogen pentaoxide. This one, this. Highly unstable product it is. So when we will heat it, you know that reaction is happening in a presence of heat. So in this heat, what will happen? This nitrogen oxygen and this nitrogen oxygen bond will break homolytically. Homolytically means equal transfer of electron. One electron to nitrogen, one electron to oxygen, one electron to oxygen, one electron to nitrogen. Because right now nitrogen is in +1 condition, and +1 nitrogen have almost equal electronegativity or even more than this oxygen. So when bond will break, equal equal sharing of electron will happen here. One electron to this oxygen, one electron to this nitrogen, due to which this oxygen with 6 electrons will generate there, and these 6 electrons are present in its outermost shell. This oxygen is known as nascent oxygen. And what about this one? Nitrogen with 1 ampere electron carrying +1 charge, rest 2 oxygens as it is. So when you will check the overall charge of the molecule, +1, -1, 0, nitrogen dioxide gas it is, NO2. Similarly, from here, one more particle of nitrogen dioxide gas will generate. So 2 nitrogen dioxide gas particles and 1 nascent oxygen is there, and water molecules are already released. Please check the mechanism of dilute nitric acid. It is similar. Only the difference is here. Now, how this nascent oxygen will bring the oxidation of phenol? It is discussed already. So the nascent oxygens, which is delivered by concentrated nitric acid, this nascent oxygen will bring the oxidation of phenol, due to which many particles of phenols will become benzoquinone. We don't want this reaction. We don't want benzoquinone. We want nitrated product, means picric acid. Then how we can stop this oxygen to attack on a benzene ring? Here we have a solution. The solution is before reacting phenol with concentrated nitric acid and concentrated sulfuric acid, add SO3H means sulfonic group on it. Sulfonic group on benzene ring. This is the solution. Don't react directly phenol with concentrated nitric acid and concentrated sulfuric acid. Oxidation of phenol will happen. Before reacting phenol with concentrated nitric acid and concentrated sulfuric acid, on phenol add sulfonic group, this group. What this group will do, let's check. Obviously, sulfonic group will be added on ortho and para positions. Suppose I have added sulfonic group on para position. Now what this sulfonic group will do, check. Sulfonic group is electron attracting group. It is an electron attracting group by two factors, -R and -I. Because it's an electron attracting group, the electron density on benzene ring will decrease. Amount of electron, or you can say electron density on benzene will decrease. Sulfonic group is attracting electron from the benzene, so electron density or amount of electrons on benzene ring will decrease. If electrons are decreased on the benzene ring, the nascent oxygen, which is an electrophile, it wants electron. For electron, it was attacking on a benzene ring, but now the electron density on benzene ring is decreased. That's why it will not prefer to attack on it. This sulfonic group is doing. It is decreasing the density of electrons from the benzene ring, due to which nascent oxygen, which is an electrophile looking for the electron, will not attack on a benzene ring, because now less electrons are available here. When electron density on a benzene ring will decrease, we will say the benzene ring is deactivated. Towards electrophilic attack. Yes, it is the right statement. Benzene ring is deactivated because electron density is less there. Electrophile will not attack on it. That's why we will say deactivated toward electrophilic attack. In this fashion, sulfonic group will help us so that oxygen, the nascent oxygen, will not attack on a benzene ring and benzoquinone will not generate. This is the solution of that problem. But with this solution, one question is obvious there. Please check. Okay, we have added sulfonic group there. And now we are reacting it with concentrated nitric acid and concentrated sulfuric acid and heating. Means we want to do its nitration. Now we know this mixture is giving us two type of electrophiles. One is nitronium ion and one is nascent oxygen. Yes, nascent oxygen is also an electrophile, neutral electrophile. In previous video, every information is given. Neutral electrophile, and this is positively charged electrophile, visible. Now, in the presence of sulfonic group, this electrophile cannot attack on a benzene ring, as I told you, because electronic density is less there. Will nitronium ion will attack? Yes, the answer is yes. The nitronium ion can still attack on a benzene ring. This is the difference which sulfonic group has created there. It is not allowing the nascent oxygen to attack on a benzene ring. That's why oxidation will not happen. Benzoquinone will not generate. But nitronium ions can attack on it And obviously all three positions, let me tell you, sulfonic group will be replaced by nitronium ion. I will tell you how. So when nitronium ions will attack on a benzene ring, almost all particles will turns to picric acid easily. Even this position will be replaced by nitronium ion. Why? Why nitronium ion is able to attack on deactivated benzene ring? The answer is this. Nitronium ion is a strong electrophile. It's a strong electrophile, and neutral oxygen atom is a weak electrophile. Now look, already benzene ring is deactivated and our electrophile is weak. Benzene ring have a shortage of electron and electrophile is weak. Will they attack? No. It is deactivated and electrophile is weak. Weak means less tendency to attract electron. So what will happen? Will they attack? No. Ring is deactivated but electrophile is strong. So even in this deactivated condition, strong electrophile can attack on a benzene ring and nitration can happen. This is the role of sulfonic group here. In this fashion, sulfonic group will reduce the chance of nascent oxygen to attack on it, and the attack of strong nitronium ion will be increased, and the major product generated will be picric acid here. Now benzoquinone amount will be negligible here. So the main product will be picric acid. Now the question arises, how nitronium ion will react with this group. But before that, I want to tell you how we will add sulfonic group there. How to add sulfonic group with mechanism we will understand. This phenol will be treated first only with concentrated sulfuric acid and heating will be done. Only concentrated sulfuric acid. This process is known as sulfonation. After nitration, I will tell you sulfonation. It is also an electrophilic substitution reaction, but in nitration it have a use. So what will happen? Obviously ortho and para positions will be attacked like this. The name of the compound will be orthophenol sulfonic acid. Here sulfonic group is a principal functional group, main functional group, and this is side one. So that's why the name is orthophenol sulfonic acid. It is paraphenol sulfonic acid, or you can call it 2-phenol sulfonic acid. 1 number to this, 2 number to this. So 2-phenol sulfonic acid, and this one is 4-phenol sulfonic acid. Sulfonation in this fashion. Just treat phenol with concentrated sulfuric acid and heat it. Let's check the mechanism quickly. Step number 1. 2 sulfuric acid particles. This is the bonding in sulfuric acid. Oxygen, oxygen, 4 oxygens are there. Out of 2 sulfuric acid particle, one will donate H positive by breaking bond like this. This H positive looking for electron will attack on oxygen of the lone pair of the oxygen, due to which 3 bonds will generate by oxygen and it will become unstable. H2 will release out. Directly I am making it. Many a time we have done it. 3 bonds oxygen will generate, so it will break 3rd bond from sulfur, and obviously electrons will transfer toward oxygen. So H2 will release out. And this sulfur, because 1 electron has gone with oxygen, so vacant orbital will generate with +1 charge. This particle will generate. Now this vacant orbital will be satisfied by this oxygen by breaking bond from hydrogen. Vacant orbital, electrons will come between this oxygen and sulfur, double bond will generate. And what will release out? H positive. What this H positive will do? It will attack on another particle of sulfuric acid and same process will start. Now, the sulfur positive charge will finish because it got one electron, this electron which was of hydrogen, now it got it in its orbital, so its positive charge will finish. This is known as sulfur trioxide gas. Sulfur trioxide gas. Now this is an electrophile. You will say how it will work as electrophile. Look, sulfur is sharing 6 electrons of it with oxygen, and oxygens are more electronegative than it. So all the electrons are passed toward oxygen. So sulfur is in +6 condition. +6, a very high positive charge. With this high positive charge, it can attract electrons very easily. That's why this molecule is working as an electrophile, a neutral electrophile. This is the first step of the mechanism. Electrophile is generated. Now electrophile wants electron. Who can provide electron? The benzene ring of the phenol. Second step. This is benzene ring. 2 positions are waiting, ortho and para. I will attack on a para position. So it is carrying a +6 charge. Firstly, when it will attack on this carbon for electron, first it should have a vacant orbital for the absorption of electron. The vacant orbital will be generated how? Out of 3 pi bond, 1 pi bond will break, and obviously electrons will shift toward oxygen because oxygen is more electronegative than sulfur. When these electrons will completely shift toward oxygen, a vacant orbital will generate on sulfur. With this vacant orbital, it will make dative bond with carbon. Now sulfur do not have electrons for the bond formation. The responsibility will be of this carbon to provide electron. How? By bringing these pi electrons toward itself. These pi electrons it will use to make dative bond with sulfur. So the next condition generated will be this. Between sulfur and carbon, dative bond will generate. And this oxygen who has broken bond from sulfur will get extra electron. So the negative charge will be there. Already 2 pairs are there. So 2 pairs these. Other oxygens also carrying 2 pairs. This will happen. Now, here hydrogen, rest molecule as it is. Sorry, I have attacked on meta. This is with para, like this. Now, this carbon has lost its electron, so vacant orbital will generate on it with positive charge. Carbocation is generated. Now this carbocation is an intermediate, obviously it will finish. How? This carbon will break bond from its hydrogen. Because this carbon has made it carbocation, it will make it neutral carbon. How? By breaking bond from hydrogen and shifting these electrons here. This is a vacant orbital. It is providing 2 electrons, bond will generate, and what will release out from here? H positive, because this hydrogen has lost its electron and H positive is generated. This H positive with a vacant orbital will attack on this oxygen. Lone pair, extra lone pair is there, -1 charge, extra lone pair, hydrogen. They will make a dative bond. And what about here? Double bond will generate. So this molecule will turns to something like this. Between this oxygen and this hydrogen, dative bond will generate. Out of 2 electrons, 1 electron it will completely transfer toward hydrogen, so its positive charge and its negative charge will finish. 1 electron it will keep with itself. Look at that. Sulfonic group. In this fashion, it will be added on para position. Sulfonic group. This is the whole mechanism. Now similarly, ortho position you can attack and you can join sulfonic group there. This whole process is known as sulfonation. And you can watch, this was an electrophile and it has replaced hydronium as an electrophile. So this is electrophilic substitution reaction. Because this sulfonic group is added there, so we are calling it sulfonation. Now, once we have generated paraphenol sulfonic acid, this one, now it's a time to do its nitration. Now we will react it with the mixture of concentrated nitric acid and concentrated sulfuric acid and heat. We know this mixture will provide us which electrophile? Nitronium. It will also provide nascent oxygen, but now nascent oxygens can't attack on a benzene ring, reason I have told you. Now nitronium ion will attack on the benzene ring. How? Let's check. You know the condition of nitronium ion. This is our nitronium ion. With a vacant orbital of nitrogen, firstly it attack on orthocarbon. Hydrogen is there. For the bond formation between carbon and nitrogen, electrons are required. Nitrogen do not have electron. So what this carbon will do? It will shift pi electrons toward itself, and these pi electrons it will use to make dative bond with nitrogen. So the next condition will be something like this. Dative bond, negative charge on oxygen, as it is. Now, when dative bond will generate one electron, this electron will completely transfer toward nitrogen here. So its +2 charge will become +1. +1 -1, the overall charge will be 0, NO2. But during this process, this carbon has lost its electron, so this carbon will become positively charged carbon. OH as it is, no change. Rest molecule as it is, no change. Sulfonic group as it is, no change. Now this is an intermediate, obviously it will finish. Who will finish? The carbon, this carbon has created this carbocation, so it will finish it by breaking bond from its hydrogen. And obviously both electrons it will transfer here. Hydrogen will release out as H positive, this one. This transfer of electron will bring double bond here. Here, NO2 group as it is, negative. Put lone pairs by yourself, +1 charge. Sulfonic group is there as it is. This one. This is first time nitration has happened here. Now, you know, when this compound is reacted with concentrated nitric acid and concentrated sulfuric acid, 3 times nitration was done. So this is first time nitration. Second time nitration. Okay, what about this H positive? What it will do? It will create nitronium ion again. Please check that video how nitronium ion was created. It will create another nitronium ion and it will be utilized. Now I am going to add second nitronium ion on this molecule. This is first nitronium ion we have already added. This one. Before introducing second nitronium ion in the molecule, one information. This carbon and sulfur, this bond length is large, almost 1.89 angstrom. A very lengthy bond it is. Why? Because sulfur atomic size is big. Sulfur is available in third energy level. Highest energy level sulfur is using third. so its atomic size is big. With its big atomic size, when it is making bond with carbon, so the bond length, the covalent bond length is long, 1.89. And as you know, the lengthy bonds are weak. That's why this group can easily leave this molecule. That's why sulfonic groups are a very good leaving group. That's why nitronium ion can easily replace it. Now let's start. With a vacant orbital, when it will attack on a para carbon, obviously nitrogen do not have electrons, vacant orbital. So for bond formation, electrons will be provided by this carbon by shifting pi electrons here. With the help of these pi electrons, it will make dative bond with nitrogen. So the next condition will be this. Pi electrons it will use to make dative bond with. Now nitrogen will get one electron. This electron will be transferred to nitrogen, so +1 charge it will have. Initially it was having +2 charge. After gaining one electron completely, +1. And this carbon has lost its electrons, so vacant orbital will come here with a positive charge. Here we have sulfonic group. Now as I told you, this bond is weak. This is weak bond. Sulfonic group can easily release this molecule, leave this molecule. So between carbon and sulfur bond will break and electrons will transfer toward carbon. Let me tell you why. If you will check the electronegativity of sulfur, it is 2.58 and carbon's electronegativity is 2.55. Almost electronegativity is same. This positively charged carbon will attract these electrons toward itself. So when bond will break, electrons will transfer here and bond will generate between this carbon and this carbon, and sulfonic group will leave this molecule. So the next condition generated will be I am writing it NO2 directly, so please check. NO2, this one. Now when these two electrons will come here, the vacant orbital and two electrons bond will generate here. And sulfur, because it has lost its electron, so on sulfur vacant orbital will generate with +1 charge. Rest molecule as it is. This will happen. Now you can check, nitro group has replaced sulfonic group. Check. Now what will happen with this one? Very easy. Vacant orbital, this oxygen will break bond from its hydrogen and electron it will transfer towards sulfur, due to which the vacant orbital of sulfur will satisfy, and between this oxygen and this sulfur, two bonds will generate. Again sulfur trioxide gas has generated. Now this sulfur trioxide gas can attack on next phenol particles for the generation of paraphenol sulfonic acid, like that. And what will release out from here? H positive. This H positive. And you can check after release of these particles what we are getting. 2 times nitration is already done. Now the third time here. So this molecule, the molecule which is generated here, will react third time with nitronium ion here. Mechanism already discussed, please check. And then finally we will get this particle, picric acid, this one. That's it. In this fashion we can create picric acid in good amount. It is in very high amount. So the final conclusion, the final summary is, quickly check. Phenol will firstly treated with concentrated sulfuric acid and heat, due to which para-sulfonic phenol I have used. Also orthophenol sulfonic will generate, but I am making para-phenol sulfonic acid. It will be treated with concentrated nitric acid and concentrated sulfuric acid, so to get a very good amount of picric acid. And if you are reacting directly phenol with concentrated nitric acid and concentrated sulfuric acid, no doubt picric acid will generate, but the amount will be very less amount, because here oxidation of phenol was happening due to the nascent oxygens which were generated from nitric acid, and most of the particles will turns to benzoquinone, this one. So this is the summary, and this is the end of nitration of phenol. Thank you very much for watching the video, and in next section we will start sulfonation, halogenation. That's it. Thank you very much.